Okay, so we have one more LT motor. You can see it's a Kirloskar LT motor. It's a 110 kilowatt LT motor, 4 pole, and that's currently in winding process. This belongs to a furnace company. Fine. So winding is all done. The endpoints are brazed. Fine. So it's a 4 parallel connection, double air winding. So now we are putting it to testing. So there's a face-to-face resistance testing that's going on. I could see that one phase has got 42 milliohms. Yeah, let's try the next one. And I'm doing this recording not only for you guys but also to share with the customer. Right? So the other one is 41.8 milliohms. Let's take the next one. And this one. Yeah, so the one is 41.9 millions. So we have 42, 41.8 and 49. Sorry, 41.9. So minor variance is because of the context that you would see there. Right? So context may not always be uniform and the clippings may not always be uniform. So this much of minor variance is acceptable. Fine. So that's micro ohms resistance that we have tested now for this winding. Let's move on to HV. Fine. Karthik, HV. So let's remove this meter. Phase to ground first and then phase to phase later. Okay. So yeah, it's, you can see it's at 2 kilovolts, right? 2 kilovolts is what we do. Fine. And the leakage current is 10 milliamperes. This is between phase and ground. Hold it for 30 seconds. Hold it for 30 seconds. Okay. Leakage current has to build. Hold it for 30 seconds. Okay. So let's see. Leakage current does not fluctuate, neither it builds. It's at 2 kV, face to ground. Fine. Let's take face to face. Face to face is just to ensure that there is no issues with the separator. Sometimes when you insert the separator, right, the conductors by mistake or human error, they would have entered the other face of it. If you just took you do from here to here, It's face to face, yeah. So the same thing, 2 kV. Leakage current is half the number now. It has to be half the number because you have 2 layers of insulation that comes down. Fine, next. Okay. The last one. Yes. This two. Do this one. Yeah. So the HV is passed according to us, and we also had taken the micro ohm resistance. They both have passed. This will go to the next phase of it now. Final binding, dipping, varnishing, assembly, trial runs, all those things. Fine. Thanks for listening. Okay. We'll be showing our varnishing process. Fine. So this is one of the trickling process that we have been using. Fine. So we have a high compressor that's going to compress the varnish through the windings. Fine. So start, Kroma. Open up. We'll just adjust the pressure a little bit. Just hold it in the center. Hold it in the center. Hold it in the center. You can see it's trickling all around. Hold it in the center. You can see it's trickling all around. You get it? It goes to the tray. And run it through the stator. All around. So this does varnishing process that we have. Stop it. And this is the tank. This is the 25-liter tank. Right. So the one part of the varnishing is done. Then I'll show the next part of it, wherein we'll not be using the spindle. We'll be just going directly for the overhang. Fine. Yeah. You can see then we will be varnishing the back side of it. Right? We will be varnishing the back side. Slow. So this is how we will be doing the back side of it. The back side is very important. The one you can see here. Right? We'll just be pouring the entire varnish throughout the winding system. Do this, you will get a very good result. This is the highest result I'll give to all my customers. You can see this is the varnishing process. Exactly this has to be done. And you can see off it. Yeah. 125 HP, 82 kVA, specialized one, 8 volt, 200 hertz. And this one is the 8 volt rotor. 30%, or rather advanced. This motor is running in star right now. Right? That's the current that you're seeing. I'll show the motor, the supply. It's another facility that we have. And same trial test is going on. So current देख लिया? 14 voltage चाहिए तो दिखा दो. Voltage flow lead तोड़ेंगे. So that's the current. 10 next time. 10, 11 next time. 12, right? Roughly more or less. Okay. And the supply will also not be always in equal balance, right? This is a kV supply, so you can understand. This is the voltage. 400, next phase, 400, 410, next phase, 410. So that's the trial run, and that's the no load current and voltage in start. Thanks.